Hi everyone, it's Mrs. Martello. We're going to start section 7.8 today. I'm on page 404. We're going to do this section in two different parts. So this is just part one of this section. We are going to learn a new way to factor, and this is called factoring polynomials by grouping. So you have to use the distributive property to factor out a greatest common monomial from a polynomial, and sometimes you can factor out a common binomial. You may be able to use the distributive property to factor polynomials with four terms as described below. So to factor a polynomial with four terms, you're going to group the terms into pairs. You're going to factor out the GCF of each pair of terms. Look for and factor out the common binomial. This process is called factoring by grouping. So I wrote down the steps here in my own words, and I think that this is going to be helpful for us to follow as our steps. I would suggest you pause the video and copy these steps down. So again, we are factoring by grouping, and this is for a polynomial that has four terms. So that's how I know when I'm going to do grouping is when I have four terms. The first thing I want to start with is the polynomial needs to be in standard form. So we want it to go from highest degree to lowest degree. If it's not, then you should really reorganize the terms and put it in standard form. Second, we're going to group the first two and the second two terms together and put them into pairs. So the first two is a pair, the second two is a pair. Now out of each group, we're going to factor out the GCF of each group. The first group will have its own GCF, we're going to factor it out. The second group will have its own GCF, we're going to factor it out. What's going to happen when we do this, something special happens here, is that we're going to be left with a common group. When we take out the GCF, what we have left will be the same for both of the groups. That's our common group, and that must happen. If that doesn't happen, then we can't continue factoring by grouping, which probably means that we made a mistake somewhere. Our last step is then we're going to factor out that common group. That common group is now the GCF of the whole polynomial. So our answer is going to look like this: the common group times the two GCFs that we took out. Okay, we're going to look at a bunch of examples here together. Let's start by looking at example 1 in the textbook. And this is example 1a. Let's do it together. We have x squared plus x cubed plus 3x squared plus 2x plus 6. All right, so let's follow our steps here. First, notice this is in standard form. This is degree 3, degree 2, degree 1, degree 0. Next, we're going to group our terms. I'm going to group the first two together and group the second two together, and I'm just using parentheses to group them. Let's find the GCF of each group. So in the first two terms, our GCF is going to be x squared. Notice how the number in front of here is just a 1. So it would be 1 and 3, so it would be 1. And remember, for the variables, you're picking the smaller exponent. That's going to be x squared. Okay, we're going to say, what do we have left when we take out x squared? Remember, when you're taking out the GCF, you're technically dividing each term by x squared. So x cubed divided by x squared is x. Carry down your plus sign. 3x squared divided by x squared is just 3. Carry down this plus sign again. Let's look at the second group. We're going to find the GCF of the second group. So I have 2x and 6. The GCF is 2. Since the 6 doesn't have a variable, I cannot include a variable in my GCF because they don't have that in common. So only 2 is the GCF. Let's take the GCF out. Remember, we're going to divide each term by that GCF. So 2x divided by 2 is just x. Carry down the plus sign. 6 divided by 2 is 3. Now I want you to notice, do you see that I am left with x plus 3 and x plus 3? That is our common group that I was talking about here. We must be left with that common group in both of those groups. They both have to be x plus 3. Now, this x plus 3 becomes the GCF of the whole expression. So I'm going to take x plus 3 out of this whole polynomial. Remember, when I take out a GCF, it's like I'm dividing this expression by x plus 3. which means both of these would cancel out. I'm going to be left with x squared. And let's divide this expression by x plus 3. When I take that out, the x plus 3's cancel, and I'm left with plus 2. That is my final answer. X plus 3 times the quantity of x squared plus 2. So just notice how the answer is written. Our common group was x plus 3 because that's what we were left with here. And then we have our GCFs, which are the x squared and the plus 2. They came together in the second parentheses. Now we can always check our work. So to check our work, all I would have to do is FOIL this back out, and I should get back the original problem. Let's show this check so that we can see that it does actually, in fact, work. So we're going to FOIL x times x squared is x cubed. Outer, x times 2 is plus 2x. Inner, 3 times x squared is 3x squared. And last, 3 times 2 is plus 6. Just to reorganize them, put them into standard form. So x cubed plus 3x squared plus 2x plus 6, and that's exactly the expression that I started with here at the beginning, so I know I got it correct. Let's do another one. We're going to look at 1b. So I'm getting this from the textbook here. I have x squared plus y plus x plus xy. So in this expression, I have two variables. Now I could leave the expression like this and I could try to factor it this way. However, this is not in standard form. Remember we said that for our first step, it should be in standard form. Okay, this is not in standard form. This term is degree 2, this is degree 1, this is degree 1, and then this is degree 2. Remember, you add the exponents together. So let's reorganize this and put it into standard form. So I'm going to keep x squared first, then I'll have plus xy, then I'll have plus x, then plus y. So notice how I kind of put them in alphabetical order. 2 x's come before x and a y, and then x comes before y. So that's the easiest way to do it, is to organize them alphabetically. All right, so now it's in standard form. We're gonna start grouping. Let's group the first two together, and we'll group the second two together. Let's find the GCF of each group. So the GCF of the first group here is just x. Let's divide each of these terms by x here. I'm gonna be left with x plus y. Carry down the plus sign. In the second group here, the GCF is only the number 1. There's a 1 in front of here, there's a 1 in front of here. The only thing they have in common is 1. I do need to take something out. Something needs to go here for my GCF. I don't want nothing. So in a case like this, I want to use 1. If I take 1 out of each of these, I'll just be left with x plus y. Now look at our common group. Do you notice it's x plus y and x plus y? Let's factor out our common group. So our common group is going to be x plus y, and that's going to be multiplied by our GCFs, these outside terms, the ones that are remaining, the x plus 1. And that would be our answer, just like that. Okay, we're gonna do some more. We're gonna look at some monitoring progress questions. Let's take a look at monitoring progress number 1. I have a cubed plus 3a squared plus a plus 3. Let's try this one. So first we're gonna look to see if it's in standard form, and this one is. This is degree 3, 2, 1, 0. So let's jump right in and let's start grouping. Group the first two, group the second two. The GCF in my first group here is only a squared. Let's divide each term by a squared. If I take out a squared, I'd be left with a plus 3. Carry down the plus sign. Let's go to the second group. The only thing this group has in common, the GCF, is 1. So I'm going to take a 1 out from my GCF. If I divide each term by 1, I'm left with a plus 3. Again, look at my common group here. A plus 3 is the common group. Let's factor that common group out, so a plus 3, and then let's write down what we have remaining are these two GCFs are going to be multiplied by that common group, a squared plus 1. And that's our answer, a plus 3 times a squared plus 1. Let's do the monitoring progress 2 from this page, just so we can try another one. All right, we're gonna look at y squared plus 2x plus yx plus 2y. Okay, the first thing we should notice in this problem is this is not in standard form. This is degree 2, 1, 2, 1. You could try to factor it this way, but it's better to have it in standard form. I'm gonna put them in alphabetical order. A y and an x come before two y's. So let's put this one first, yx, then plus y squared. Then I'll put again the x before the y, plus 2x plus 2y. So again, I'm doing alphabetical order and in standard form. All right, now we're ready to group them. Let's group the first two and let's group the second two. The GCF in the first group is just y. Let's take y out of each term. I'm left with x plus, take y out of here, just one y left. Carry down the plus sign. Let's go to the second group. Our GCF here would be 2. If I take out 2 of each term, I'm left with x plus y. Notice how I'm left with this common group, x plus y and x plus y. That's going to be the first group in my answer, x plus y, times our GCFs, y plus 2. And that would be our answer like this. Okay, now all of these were positive numbers. Let's try to get some negative numbers involved here so that we can see what happens when we start including negatives. So the examples that I'm going to do now are not in the textbook. These are extra examples that I'm just going to create here for us. So I'm just going to call this extra examples. And let's call this number 1. All right, let's do 8s cubed minus 64s squared plus s minus 8. Okay, let's notice that this is in standard form, degree 3, 2, 1, 0. So I'm ready to group them. Let's group the first two and we'll group the second two. We'll find the GCF in each group. Make sure you look for the numbers and the variables. So between our numbers, our GCF is 8, and then for our variables, the GCF is s squared. Remember, we picked the smaller exponent. Let's take this out of each term. The 8s would go away. S cubed, take away s squared, would just be s. Carry down the minus that's in the middle. Again, we're dividing. 64 divided by 8 is 8, and then the s squareds cancel out. Carry down the plus in the middle. In our second group, I have s minus 8. The only GCF here between these two is the number 1, and I'm left with s minus 8. Notice our common group is both s minus 8. That's going to be the first part of our answer. And then let's group together our GCFs, which were 8s squared plus 1. And that's our answer just like that. Okay, let's take a look at another one. Let's call this number 2. 21h cubed plus 18h squared minus 35h minus 30. Okay, let's factor by grouping. Again, we have 4 terms, so that's how I know I'm factoring by grouping, because I have 4 terms here. And this is in standard form, so I'm going to start grouping them together. Group the first 2. Let's include that squared in there. Okay, now be careful. When you go to group the second 2, this 35 is really a negative 35. It's not a positive 35. So when I do this, I need to include the negative in with the 35. So what I'm really doing is I'm really changing this to be plus negative 35 so that that negative can be in the group with the 35, and then there's a plus in between the two groups, just like how there's a plus in between all the other groups we've done so far. Okay, so I'm going to write myself a note. I need to make sure that there is a plus between the two groups. So if I have to, I can change that minus to plus negative. Okay, we want a plus in between the two groups. All right, so now let's factor by grouping. We'll find the GCF of each group. Make sure you look for the numbers and the variables. 21 and 18, they have 3 in common. H cubed and h squared. The smaller exponent is h squared. Let's take that out. Remember, we're dividing. 21 divided by 3 is 7. H cubed divided by h squared is h. Plus, dividing 18h squared divided by 3h squared is 6. Carry down the plus in the middle. Let's go to the second group. Now both of these terms are negative in this second group, so when this first term is negative, remember that has to mean that there's a negative GCF here in this second group. So I need to take out a negative GCF, which would be negative 5. If I take out a negative 5, I'm left with positive 7h. Take out a negative 5, I'm left with positive 6. Look at my common group here, 7h plus 6, 7h plus 6. That's going to be my first group, 7h plus 6. And then in my second group, 3h squared. And then instead of saying plus negative 5, I can just say minus 5. So I just want to note here that this one has a negative GCF for that second group, and that's all because that first term in this group was negative, so I needed that negative GCF, and this is our answer here. Okay, let's do another one. Call this number 3. Let's do 4x cubed minus 12x squared minus 5x plus 15. Okay, notice that this is in standard form. Let's start grouping. I'm going to group the first two terms together. Now this is another case where there's that minus in the middle. Let's change the minus so it's plus negative, and I can have that negative in the group with the 5. This is really a negative 5, so I don't want to separate the negative from the 5. Okay, let's find the GCF of each group. In the first group here, I can take out 4x squared. When I divide out 4x squared, I'm just left with x minus, dividing again by 4x squared would be 3. Let's go to the second group. Now again, my first term in the second group is negative. Whenever the first term is negative, I need to take out a negative GCF again. So let's take out that negative GCF in this group. Well, the numbers just 5x and 15 would be 5, but let's take out negative 5 so that I can make this first term positive. If I take out a negative 5, I'll be left with x. And the second one, remember, we're dividing. Positive 15 divided by negative 5 is negative 3. Notice how I'm left with this common group, x minus 3. Again, that has to happen. If I had taken out a positive 5, then this would have been negative x and plus 3. This would not have been the same, so that would not be allowed. I need these two to be exactly the same. So let's go ahead and finish up this problem. My common group is x minus 3 times the remaining terms, or the GCFs, would be 4x squared minus 5, just like that.